Hello again from Skip, Victor Echo 6 Bravo, Golf Tango. I'm back with the third or part 3 of the IFR repair work. This is a signal generator I drugged back home from visiting Dave out on the west coast. It's an IFR 2025 and it's a nice looking unit. It goes from 9 kilohertz to 2.5 gigahertz. But it has an issue. When you turn this thing on and figure out how the buttons work, you look at the display and you see this little error message, error 5021, fractional and loop high. Oh boy, that sounds like fun, doesn't it? And then you hook up a scope to the output, and what you should be seeing is a nice sine wave. I don't think so. Look at this lovely looking mess. So I get the cover off it, and I'm looking down at this thing, and I'm saying to myself, where's all the RF stages in this thing? This is more like logic and control. Oh boy. I flipped it over then and had a look on the other side. So after taking a crap load of Torx head screws off this cover, this was exposed, and I looked at this and figured, oh good grief. This is not going to be easy, not like the old 1200 was. But anyways, I proceeded on. I got a closer look down into some of these chambers or areas, and oh boy, there's some small parts in here, but nothing I probably couldn't handle, but just where to start. So I went online, looked up the model number, and lo and behold, found a service manual for this darn thing, and it was very helpful. There was a section in it called General Synthesizer Fault Diagnosis. So there's a bunch of steps here to check this and check that, and I found out where the area the trouble is coming out of anyways. I could see that there's some signals in here just were a mess. You know, they shouldn't look like this whatsoever, and some of the voltage were fluctuating, and you know, and I knew, well, it's in here, well, so what now? I'm going to start replacing parts, and I wasn't sure how to proceed. So I got talking with Dave about it. So Dave tells me there's an IFR forum on the net, and there's an expert on there, quite knowledgeable fellow on IFRs, and he said the first thing to do with this machine is replace all the capacitors, all the surface mount capacitors, because this ESR value. And I said to myself, ESR? I've heard of that, but just what is it exactly? Hey, I'm an old dog, but you can teach me a new trick any day. So I figured before I do anything drastic, I've learned that you can find a lot on the web and make things a lot easier to fix things. So I proceeded on taking all these capacitors off, all the little electrolytic can type ones. There was 100 microfarad, 47, 22, and little 10 microfarad capacitors. They weren't too bad to get off. The ones that are really tight against the walls, so I melted some of the plastic holders with my soldering gun getting them off, but they came off. So I got them all pulled off, and I wound up with a little plastic lid here of little aluminum cans. They're not very big, but actually I thought it'd be a lot more, because when I first looked at the machine, boy, it looked like there's a lot in there. So capacitor testing, you know, I'm an old TV repairman. That's basically what my first background was, and you know, back then capacitors are capacitors. I replaced them if I saw them flying, you know, exploding and flying through the air, or just starting to blow it up and look like like a pregnant capacitor, or just starting to leak. That's when I changed them out. But this is different, and this little device for checking components I really love it. So ESR, equivalent series resistance, as you'll see what it comes down to in this measurement. Okay, everybody's got one of these things. I mean, these things are the best things since sliced bread, and up to now I've been using them mostly just for identifying transistor legs and FETs and stuff like that, just to find out what's what when I go to install them. I mean, you can't beat it. You know, I've worn out the little socket using it, so now I got alligator clips, and this is what I use. So this is the only thing I've got lately now to check capacitors in any detail, and it seems to do the job. So this is interesting. So I'm going to grab one of the old capacitors I took out of that generator. It's one of these little babies. I get a hold of it with my fingers here. It's a, I don't know if you can see it, 100 microfarad. So, again, I like about this little device, it doesn't matter what lead you use, just as long as you get them clipped on there, and that's half the battle. Stick it on there, get the red one out of the way, push the button. Yeah, it's testing it. There it comes up. So I don't know if you can see that. I'm going to zoom in a bit. 103 microfarad, which is what it is. But take note of the ESR, 3.6 ohms. That's up here in the corner. So now we'll... that was one of the older bad ones. Now, older bad. One I replaced anyways. But it's not the worst. So now we got this one. This is a brand new one. It's a 100. You can see it on there. I ain't gonna fold. There we go, 100. So it's much bigger. It's a bigger voltage one. I don't have any new ones. I got them all installed in the generator already. So this will have to be the next best thing. Oh, hit the button. Like I said, this thing is just too damn handy. Zoom in again. There it is. 96 microfarads. But look at the ESR. 0.91. So that's telling you something right there. Now, the ones that are really noticeable is, okay, I'll take, from what I understand, this is probably the ones that did that generator. These are little 10 microfarad, if you can see that. If I can get the leads on this thing. I mean, these leads are pretty small. Get them on there. See if they make contact here. We'll kick it on. "10 microfarad, but look at the ESR, 7.9. I found that interesting. Now, I got two types here. That was 7.9. Now, I have, this is what I put in, this is the ones I put in there. Again, they're 10 microfarad. And hit the button. Oop, didn't go. There we go. Testing. 2.5. So it's less. A lot less. Now the ones I wanted to use, these were, this one here, the ones I put in are just aluminum caps, 10 microfarad. Yeah, they're good ones. So the ones I wanted to put on were these, I think they're called polyaluminum? I can't remember. What's it say here? Yeah, poly. But they were too big. I couldn't get them to fit physically. Just couldn't get it. But I mean, these are probably, probably a lot better capacitor. Again, you can see it on if I get it up right. 10 at 20. You see some solder on there. I tried to get these in there, but I just couldn't make them fit. They're just, the footprint was just too big. But look how good these are. And this is what Dave was wondering if we should use these, but I couldn't get them to fit, Dave. Sorry about that. But yeah, look at that. 0.47. A much better capacitor. So this is what I've done. I've replaced all those capacitors in that generator. Interesting, isn't it? I think so. So I'm not going to get into ESR real deep. I'd suggest if you're curious, look it up on Google. There's lots of it on there. And there's a lot of people saying things about what it should be and what they shouldn't be for values. So take all that with a grain of salt. I just know that it worked. Anyways, I had all the capacitors pulled out, and what I did, I took pictures. You saw some of them earlier of the individual boards, so I could identify where the capacitors go back again, and mostly the polarity. It was a couple of weeks before I got back to this thing, and without pictures, it would have been a bear cat trying to just go by the schematic and trying to figure where they go. So I proceeded and put them all back in. After getting them installed, I turned on the power and looked at the display, and look here, no error messages, and everything looks good. I was actually kind of surprised. So I guess shotgunning all those capacitors, fixed it. There's probably only one or two of them that was really killing it, but this is easy, and I guess they're all kind of drying up or whatever's happening to them to make them go bad like that. So, yeah, I was tickled pink. They hooked up the output, and this is what it looks like on the scope now. A lot better than it did before. Well, I was feeling pretty confident and on the roll now, so the next thing to fix is the push buttons or the keypad. This thing, they're very... Well, a lot of them didn't work. You had to push really hard on the buttons to get some to work, so it was time to tear this apart, and it was usually just clean the contacts. So the front panel came off this unit rather nicely. Everything unplugs, and I got to say, this thing is built rather nice, especially the surface on it. Next, I pulled the display board off. It was kind of in the way a little bit on one side. Then finally, the keypad contact board itself. I lifted off and looked good, but I pulled it and the rubber pad off and cleaned it with some cleaning solution, kind of an alcohol-based contact cleaner with a Q-tip, and put her back together. Working on this new machine here. I've got to fire it out and working on the different counters. Right now I'll put it in my HP counter. So I got it set for 500 megahertz right on the money. So it goes out, goes up into the counter. Now this HP counter is referenced to a 10 megahertz lock on the GPS satellites, and so we can see it's somewhere around 700 hertz off, and that varies from frequency to frequency, of course. So we'll fix that. We're going to get everything on one standard. This is my GPS 10 megahertz reference system in my 2.4 gig shelf. I see different coaxes there go out to different sources for calibration, or locking into the standard with all my counters and stuff. So what I've done here, run a coax out. It's actually two coaxes. This one here, anyways, goes up to the back end of my HP counter into the external reference in. That output there goes down to another machine, but we're not using it, so that's how that works. So I had to download a manual to figure out how to get this thing switched over to an external reference, because right now it's working off the internal reference. So to do all this, we'll zoom in on the screen a little bit here. Right now, so we'll leave it at 500 megs. Menu. And then since we want frequency sweep to do frequency, we'll hit select again. If the button will work, there we go. I'm already on frequency standard because I've already done this, so just kind of streamline it a bit for you guys. Hit it again. So right now, frequency standard is saying 0, and 0 is internal. We want internal 10 megahertz direct, so we'll pick number 1. There's number 1. So let's pick number 1, external 10 megahertz direct. Okay, we'll go out of here. Go to menu, carrier frequency. Okay, we're on 500 megahertz still. And we'll just go up here a bit. And look at that. Right on the money. 500 megahertz. So now I'm going to go up to 1 gig. 1.0. If I can find the gigahertz button, there we go. 1 gigahertz on the money. And this display down here says the same. You can see, I'm not going to move the mount for this, but we'll go up to, let's see, this thing only goes up to 2.5 gig, so 2.5 gigahertz. So it says. All right. Pretty darn close. So I'd say this thing's working anyways, for this part of it. It's always nice to get everything on one standard. If you don't have it all on the same standard, you're going to see a little bit of difference here and there. So it's handy to have a good 10 megahertz reference to run around the shack. I'm going to check the RF level output in this thing. Now, you got to remember, my power meter here, when was the last time it was ever sent away and calibrated? So I use this internal reference for zeroing, and it's within like 0.04 dBm. You notice on the generator it's at 0 dBm right now. So we're going to go up in steps. I'm going to go positive first here. There's 1, and it's ranging. 1 dBm, 2 dBm. So with a little offset of my power meter, I'd say this generator's dead on the money. 4, 5, 6, 7, 9. I don't remember how high this thing goes. It'll tell me. The generator, that is. 13. That's it right there. RF level limit. So that's as far as we go. So we'll go back to 0. Oh yeah, my things are ranging here. Yeah, 0 ranging up. Now I'm going to. Is this still? How do I get that to work? Yes. Well, let's not worry about it. Okay. We'll go down. Now my power sensor is going to be a little off on this one. I'll have to change it out to pretty close to get it really down where it goes on a long ways. I'll do that here eventually. So, yeah, I think I got to change the sensor. So that's next. All right, I got the different sensor on here. On the power meter. This sensor starts at negative 20 dBm, it goes down to negative 70, so that's why I got to start at negative 20, otherwise it goes into overload situation. So we'll see if I get going the right direction here. Oh, went the wrong way. Okay, so we're back to 20 here, 19.99 here. So again, calibration. So there's 21, there's 22, 23, 24, 25, negative 25 that is, 26, 27, 28, 29, 30. I'm not sure how far the generator goes, we'll find out. Power meter goes to 70, negative 70. 34, yeah, pretty close. 35, 36, 37, 38, 39. There's 40, 39.99, 41, 42, 46, 47, 48, 49, ranging, okay, that's 50, 51, I guess we let it settle in, 52, I'm going to bounce in here, 53, 4, 5, 6, there, settle in, 57, 58, 9, 60, 61, 62, there, settle in, now we might, one of them is, oh, there's 64, 65, getting way down there. I think my power meter's only goes to 70, yeah, so it's probably losing it. So settled in 68. It's gonna get there, yeah, and passed. So pretty darn close. I mean, I'm really down there in signal strength. 70, and I think that's as far as, that's what the power meter rating goes for. Let's just see what it'll do. I'll jump ahead here a bunch. It's taking too long. Oh. Oh boy, it's still going though. Look at that. Yeah. She's at its end. Anyways, I'd say it's pretty darn good. So turn carrier off. Off and carry. Yeah, look at it. It's so weak that it's, you know, floating around with the carrier. I guess I could. Do I have the carrier turned off? Yeah, off right here. It says, yeah, so turn it back on again. Turn it back on again. Yeah, nice machine. Anyways, pretty darn close, I'd say. Hey, just for giggles. I mean, I was at 500 megahertz. Let's go up to 1.5 gigahertz. See what this thing does. So, carrier frequency 1.5 gigahertz. There we go. Carrier's on. I didn't recalibrate this for the frequency. We'll just leave it there. See what it does. So we're on there, negative 20 dBm, negative 20 dBm up there. Now let's go down. I gotta turn. I'm on Fred curve. Sorry. RF level. There we go. Now go down. 21, 22. Let's speed this up. Let's jump here in numbers. Let's go to 30. Negative 30, negative 30. It's 1.5 gigahertz, remember? Let's go 40. One more time, 40. Yeah, pretty good. Let's go to 50. Again, good. Let's go to 60. Yeah, it seems like this thing works better at a higher frequency than 500 megs. I think I'm good to 70, so let's go to 70. Yeah, it's a little wobbly, isn't it? If we go lower, let's go to 75. Yeah, my sensor starts to lose it. It's only rated to 70, but it's, it's still measuring things, but yeah, it's floating all over, so no, that's it for the power sensor. You get within range, it works good. Anyways, I'd say it's a good working unit. I love playing around. So that pretty well wraps it up. This is a nice signal generator. I'm glad it's working again. I am also very surprised at how easy it was to get it fixed by shotgunning all those capacitors. And an old dog learns a new trick every time. This ESR thing is something I never gave a thought of before. So, hey, something learned. So, hope you enjoyed the story of the 3 IFRs. I had a lot of fun playing with these crazy things. So, thanks for watching. 73's from Skip. Victor Echo 6, Bravo, Golf Tango.